Hello everyone. So today at the first online class, I will try to explain the analysis of a frame with sides by using stiffness method. So this is the problem which you can see on the screen. So this is a frame with columns of different heights subjected to axial load as well as UDL on the beam. So axial loads are acting on both the columns and UDL is acting on the beam. So just to recall, I would like to recall some of the concepts which we have already learned. First thing, to solve any problem using stiffness method, we have 6 steps. Step 1, identifying the unknowns. So how do we identify the unknowns? Whenever there is a sway, we have one unknown in the form of delta that will deflect towards right or left. And then we have rotations at joints B and C. So whenever we have a rigid joint in frames or a roller support or a pinned support, we have a rotation there. So here we have joint B and joint C as rigid frames. So that is where we have 2 rotations. And then we need to calculate fixed end moments based on the loading conditions and then formulate the stiffness matrix. Size of stiffness matrix will be equal to number of unknowns. And then we need to write the equivalent joint loads. So equivalent joint loads can be categorized into 2 categories. One, directly the load acting at the joint, and the second one, equilibrium conditions and shear conditions. And the fourth step is identifying or calculating the unknowns. Fifth step is calculating the unknowns, and the last step is calculating the final moments. So here we'll start this problem. So the unknowns in this problem are delta because of sway, theta B, rotation at B, and theta C. And the fixed end moments corresponding to the given loading conditions, there is an eccentric load on the column AB, that is minus WAB square by L square, and BA will be WBA square by L square, and then we have BC minus WL square by 12 and CB plus WL square by 12. Then we have CD, so minus WAB square by L square, and MFDC minus WA square B by L square. So once we have calculated the fixed end moments, then we go to the stiffness matrix. So as I've already explained in earlier classes, so stiffness matrix can be obtained based on the unknowns that were chosen in the first step. So here, stiffness is defined as the force per unit deformation, and we have 3 components here, 1, 2, and 3, as shown in this figure. So now we have K11, K21, K31 corresponding to the deformation component 1, that is the force at 1 due to unit deformation at 1, force at 2 due to unit deformation at 1, and force at 3 due to unit deformation at 1. So now if we go further, we also have this K22, K12, and K32. Similarly, for the third parameter, that is rotation at C, K13, K23, and K33. And we know that one of the important property of stiffness matrix is that it is symmetric in nature. That is, Kij is equal to Kji, which means K12 is equal to K21, K13 is equal to K31, and K23 is equal to K32. So going to the next step, so if you see K11, we have K11 here, so corresponds to the translation at this joint. Because the frame is under sway condition, the 2 columns will be displaced. So in order to calculate the translation for this column, we need to take 12VA by L cube plus 12VA by L cube and their corresponding moment of inertia. And we have a translation here and then the rotation here, which means unit deformation is applied axially, and we need to calculate the force in the rotation direction, that is B. So there we have minus 6EI delta by L square. So that is minus 6EI delta by L square. That's what we are trying to see here now. And correspondingly, K13 is also minus 6EI delta by L square. And L corresponds to the column AB and column CD here. Delta will be equal to 1 because this is a unit deformation one. And then K12 is equal to K21 and K13 is equal to K31. Then we have K22. So when you go to K22, we have an option of choosing this specific parameter, K22. So we apply unit deformation in this direction and in this direction. So it's a joint. connected to two members and it's a rotation. So we have 4A by L plus 4A by L and corresponding moment of inertia should be calculated. And then K32 is the far end for K22. So this will become 2EI by L. So K32 will be equal to K23. So then we go to this frame, this specific applying unit deformation at third unknown parameter. So here we have unit deformation applied in this direction. So K33. So we have rotations for CB and CD. And previously we have for AB and BC. So this is 4A by L plus 4A by L. And the moment of inertia of the corresponding member should be written. So for K33, far end will be K23, and that is 2EI by L. So now, so after writing the stiffness matrix, we have got a 3 by 3 stiffness matrix. And the next step would be equivalent joint load. In equivalent joint load, one of the important parameter is that we need to solve the problem using the same way that we have done for slope deflection and moment distribution method. That is calculating the horizontal reaction at A and horizontal reaction at D. Horizontal reaction at A is calculated by taking the moments at the top joint B for this column and top joint C for this column, that is BA and CD. So when you take the moments about the top column joint B, we'll get MFAB plus MFBA minus 100 into 4 is equal to HA into L, that is the height, that is 10 meters. And we get HA is equal to 35.2 kilonewton. So MFAB and MFB are the fixed dead moments. So similarly for HD, using this expression, we get 32.4 kilonewton. Now the sign convention that is followed here, any load acting in the direction of sway is positive and away from the direction of sway is negative. Now the equivalent joint loads are given by P1, P2, P3. P1 is equal to P1 dash minus P1 double dash and P2 is equal to P2 dash minus P2 double dash. So P3 is equal to P3 dash minus P3 double dash. So P1 corresponds to delta, P2 corresponds to theta B and P3 corresponds to theta C. So P1 dash, P2 dash, P3 dash corresponds to the horizontal loads acting at the joint that has to be stressed. So it's a load acting at the joint. So that is a very important parameter that we need to understand. Now, when we wanted to understand this is very important. We should not take those loads acting on the members. We should only consider the load acting at the joint. Next part. So this is a very important point. And the next part is the calculation of P1 double dash, that is sum of horizontal reactions at the joints B and C due to sway. So if you see here, the consideration is we have understood that the sway is happening at this joint, the joint B. So we need to calculate horizontal reactions at that joint. So to calculate the horizontal reaction at that joint, we need to subtract 100 minus 35.2. So you'll get 64.8, that is minus. Similarly, 50 minus 36, 24 positive. And the sum of horizontal reactions at joint B will be, as I said earlier, away to the direction of the sway is negative. So minus 64.8 plus 17.6. And so this is the P1 double dash. So P2 double dash is the equilibrium condition at joint B, that is MFBA plus MFBC. And P3 double dash will be MFCB and MFCB plus MFCD, fixed dead moments. So once we obtain the equivalent joint loads, we need to calculate the unknowns. Unknowns are calculated using the expression K delta is equal to P and delta is equal to K inverse P, and we get the values of delta, theta B and theta C. In the next step, we need to calculate the final moments. MAB is equal to MFAB plus 2A by L into 2 theta A plus theta B minus 3 delta by L. Here theta A and theta D are 0 because they are fixed conditions. One more thing is that this is very important. 3 delta by L should be considered only for columns and not for the beams. That's why you could see it at MAB, MBA MCD, and MDC. Then another condition that is required is that equilibrium condition, that is MBA plus MBC should be equal to 0, and MCB plus MCD should also be equal to 0. So finally, after calculating all the final moments, so we need to sketch the bending moment diagram. One is the moments obtained due to fixed end moments and the final moments. And we need to calculate the moments obtained due to simply support condition. And accordingly, we will sketch the bending moment diagram as shown. So if you have any queries with this problem, you can text me a message regarding your doubts. I can clarify on a timely basis. Thank you very much.